NServiceBus is a messaging framework which makes it easy to send, process, and publish messages on a wide variety of on-premise and cloud-based queuing technologies. In an earlier video, we learned how to get started with NServiceBus on AWS using SQS Transport. We learned how to send commands and have it processed in a background running process using NServiceBus and AWS SQS Transport. In this video, let's learn how to publish events using NServiceBus. An event is another type of message which can be published and can be received by multiple receivers. We will learn how to publish an event, set up multiple subscribers, and how it works under the hood using SQS Transport. Hello everyone, welcome back. If you're new here, my name is Rahul and I make videos around .NET. This video is sponsored by AWS and is part of my AWS on .NET series. I highly recommend checking that out if you are a .NET developer building applications on AWS. Without much delay, let's start publishing some events using NServiceBus. Here, I have the solution that I used in the previous video where I show how to set up NServiceBus and send a command. Now, if you're completely new to NServiceBus on AWS, I highly recommend checking that video first before continuing on this one. It will be linked here and in the descriptions below. I'll do a quick walkthrough before we proceed on with events. So here we have a user API, which is an ASP.NET Web API, which has the program.cs and also the controller. In here we have the user controller, which sends and gets a user. Now in the post, I used NServiceBus, I injected in the iMessage session, and I send a new create user command message inside this post method. Now in the program.cs, I have the code that's required to set up NServiceBus and send these messages to the appropriate endpoints when saying this create user command. In this particular case, this is sent to the user service endpoint. You can also see I'm using the SQS transport and have set up S3 for large messages. This endpoint is configured as send only. Now coming to the user service, again we have a create user command handler which handles the create user command. All this does right now is log the message. This is the handler where you would normally write your application and business level processing. In the program.cs, we have set up the endpoint as user service and configured to use SQS transport. As before, this is also using S3 for large messages. Now in this case, we have enabled installers to automatically create the queues and the infrastructure that's required for this endpoint. We also saw underlying how it creates the SQS transport when running these applications. Navigating over to AWS Explorer, which is part of the AWS toolkit, you can see the different infrastructure elements that gets created when you run this application. So under Amazon SQS, you can see two queues that was created, which is the error queue and also the user service. Let's run this application to see this in action. Now this is set up to run multiple projects, which starts the user service and also the API. Now in this case, if I was to post a user, so let's say try it out and click execute, this is going to be sending a message using NServiceBus, and you can see this in the console application, which is the user service getting processed. Now let's see how we can publish events and have multiple consumers receive these messages and process them separately. So let's stop this application and publish our first event using NServiceBus. So let's come back to our Solution Explorer. Under the user messages, let's create our event. So in this case, let's create a new class and let's call this as user created event. So you can call user created event. Now as a convention, I'm using event in the end of events and commands at the end of commands. Based on your team and organization, you can stick with this or use other conventions. So let's click add. And let's call this as a I event. This comes from the NServiceBus library. So let's make sure to implement that interface which marks this particular class as an event. Now in this case, all we need is a new property, which is the user GUID. So let's add a user ID and make sure this is getting set as part of the constructor. So let's create the generate constructor, which automatically creates and sets the user ID. Now that we have the event, let's come back to our create user command handler, which is where we are creating users. So let's publish this event right after the creation of user. So let's assume we have the business logic here, which creates the user, and let's publish the event. So we can use the context method, which comes in as part of the handle method. So let's use context.publish, which is the method that you need to use when you have to publish events. Earlier, when we were sending commands, we used the send method. So let's call the publish and let's create a new instance of the user created event. So let's pass in the message.id, which is the user ID in this case. Now let's make sure this constructor and the class is public. So let's make this as public. And we are successfully publishing this event. Now since this is an asynchronous call, let's make sure to add the await call and make the method as async. Now we no longer need to return the task.completed task because we have an await call inside. Now with this code, we are going to successfully publish a user created event as soon as we handle the create user command and are done with creating the user. Now let's add in a new service that will handle the user created event. So let's assume in our application we have a payroll service which is interested anytime a new user is created so that it can set up the payroll related activities for that user. So let's go and create a new service very similar to our user service and call it payroll service. So let's right click on the project and say add and select new project. We will create a console app again. So let's click next and let's call this as payroll-service. Let's click create. Now since we need the exact same program.cs from the user service, let's copy this and make sure to copy that inside our payroll service. So let's remove and paste this in. Now this console application has some missing NuGet packages. So let's make sure to do control dot and install the package NServiceBus. Let's use the local version 7.8.0. We also need to add the SQS Transport, which comes from the NServiceBus.SQS library. This also requires the NServiceBus SQS library, and since it's not coming up on the control dot, let's right-click the dependencies and say Manage NuGet Packages and browse for NServiceBus SQS. And let's add the NServiceBus Amazon SQS package. Now once that's installed, we should have all the NuGet packages that's required for this new service. Let's also make sure to update the endpoint name. So let's call this as payroll service. And this is still using the same S3 bucket. To handle the user created event, let's add a reference to this library. So let's right click and say add project reference and add in the user.messages library and click OK. Let's create a new class which is called the user created handler. So let's say user created handler and let's handle messages, which is again an interface coming from NServiceBus, and specify user created event. Let's make sure to implement this interface and let's do a logging as before in this example. So let's get the logger similarly. Let's paste this in. So instead of create user handler, we can specify user created handler, which gets the appropriate log instance. Once we have the log instance, let's use that to log the message. So let's say log.info. Let's specify string interpolation and let's say payroll service user created handler for user ID, and let's pass in the message.id, which is the user ID. Now all this is going to do is log this. In a real world application, you would be handling the appropriate code for payroll service. Now similarly, let's simply return the task.completed task so that this builds appropriately. Now that we have everything set up, let's run this and make sure it's working as expected. So let's navigate to the Solution Explorer, right-click on the solution, specify Set Startup Projects, and also add the payroll service. So let's make that into Start so that we are right now starting the API, the user service, and also the payroll service. So let's click apply and click start. Now this has launched the web API where we can publish a new user. We also have the user service and the payroll service running right here. So let's keep all these in our window and let's post a new user. So let's click try it out. Let's specify Rahul and let's scroll down and click execute. Now this is going to send the message into the user service, which handles this appropriately, and it publishes a new event, which you can see immediately being handled inside the payroll service. So here we have the payroll service user created handler for this new user that was just created. Now if we have multiple subscribers, all these subscribers is going to get invoked at the same time. So if we come back to our solution, let's stop this and let's add a new service very similar to the payroll service. So let's call this as the task force service, which is responsible for managing the task force at our company. So let's right click and specify add a new project and create a new console app. So let's call this as task force service and let's click create. Now very similar to the before one, let's copy the entire code and let's paste this in here. Let's also make sure to include the appropriate NServiceBus libraries. So let's install that. And like before, let's also install the SQS Transport. So let's right click, manage NuGet packages, and let's browse for NServiceBus SQS and add that to this library as well. Now in this case, let's again add a reference to the user messages. So let's add a project reference and specify user messages and click OK. Let's add a new handler. So let's again call this as user created handler, which is going to be very similar to our user created handler in payroll service. So let's copy this code and let's paste this inside here. Now this is going to create the user created handler inside our task force service. Now let's come back to program.cs and let's call this as task force. Now with everything set up, we have two handlers for the user created event. So one we have it in the task force service and the other one inside the payroll service. Now let's right click the project. Let's set up the startup projects like before and make sure to start the task force service as well. So let's make this a start and click apply and OK. Before running this, let's also make sure the text in the task force service is handled appropriately. So instead of payroll service, let's update this as task force service. Now once that is all set up, let's start this application. Now it's going to run the API and the three services in the background. So we have the API running here and we also have the user service, the task force service and the payroll service all running here. Now with all the three services running, let's come back to our API and let's publish a new message. So let's create try it out. Let's specify the name and let's click execute. Now this is going to be handled by the user service, which is going to process the message, create the user and publish the event. Once the event is published, it's going to be handled by the payroll service and the task force service. Now you can see both of them has logged the task force service user created handler for the user and the payroll service also does the same. Now in your real world applications, you would have appropriate code which fires off on both these services. Now that we are successfully able to publish an event and subscribe multiple consumers to that, let's see how this is working under the hood. So let's stop this application and let's navigate to the AWS Explorer. So let's make sure to refresh this and we can see now here we have a new Amazon SNS topic also created and we have a few other services. Now inside this is a new topic that was created, which is user_messages user created event, which is the exact same event that we were publishing. We also have two new queues in here, which is the payroll service and the task force service. Now if we navigate to the SNS, you can see this has two subscriptions under that. Both of them are SQS subscriptions. Now if you're completely new to Amazon SNS, I highly recommend checking out my video linked here or in the descriptions below. I walk through the different features and properties of SNS. Now, one of the features of SNS is that you can plug in other SQS queues as subscriptions to it. So as soon as you publish a message into the SNS, this message will get delivered to both the subscriptions listed here. In this case, you can see both of the messages are getting sent to the payroll service and the task force service, which has the appropriate handlers for the user created event. Now, NServiceBus automatically detects that we have handlers in these services and wires this subscriptions for us. Now, anytime you send a message to the SNS topic, a copy of that is sent to both these queues. Now, both these queues have their own services listening to it, which is the payroll service and the task force service. As soon as messages arrive in there, the service picks that up and hands off to the appropriate handler. Now, let's see this in action by just running the API and the user service. So let's right click on the user API, debug and start new instance. Similarly, let's also run the user service. So let's right click and say debug and start new instance. Now we only have the user service and the API running. So let's send a new message. So let's say try it out and let's specify the name. So let's say Rahul and send execute. Now let's say we send one more message. So let's call this as AWS and click execute. So we have totally sent two messages. Now both of them were processed by the user service, which would have published the appropriate events into the SNS topic. Now if we navigate back to the Visual Studio and go to the AWS Explorer, let's navigate to payroll service and double click that. And here we can see two messages inside payroll service waiting to be processed. This is because we haven't run the payroll service yet. Now you can look at these message body and this is the message that we have just sent, which has created the publish event. Now if we double click to open this message, you can expand and see the message content. Inside here, you can see that this is of type user created event. This is the event that we have just published when we processed the message. Similarly, if we navigate to the task force service, you can see two messages in there as well. Now, as soon as these services come back online, it will process these messages. So let's go to Solution Explorer and let's start the task force service. So let's right click and debug, start new instance, which is going to process these two messages. Now you can see this is processed both these messages. So if we come back to the queue and refresh this, both these messages would have gone. Now the messages still exist for the payroll service because that service has not yet run. Now if we come back to Solution Explorer and run the payroll service again, so let's start debug and start new instance, which is going to pick up the messages that's waiting on this service. Now all the messages have been successfully processed. Now as you can see, these consumers doesn't have to be online all at the same time. So if your payroll service is down for maintenance or due to other reasons, it will accumulate all the messages and events that it gets in its queue. As soon as a service comes back up online, it can look at its own queue and process the messages accordingly. Now that we understand how this works internally, let's also take a look at the topology diagram for the SQS transport. Here, we can see a breakdown of how the SQS transport and the various underlying components interact with each other. Now, when you send a message from an endpoint, it sends it to an SQS queue, which is represented as this icon in here. When you send a message, we explicitly specified the endpoint name. In this case, the send sends it to an SQS queue, which is received by the receiver. So now this endpoint belongs to endpoint B. Whenever you're publishing an event, you publish that into an SNS topic. Now these SNS topic has appropriate subscribers using SQS queue. So anytime we publish a message into this particular topic, all the subscriber SQS queues receive a copy of that. So this is automatically getting sent to this particular SQS queue. Anytime the message is larger than the allowed size, it stores the message in the S3 bucket and simply sends the reference to that message in these messages to the queue or the topic. So as soon as the receivers get it, it picks up the message from the S3 bucket and processes it accordingly. We saw how all these different AWS components come together when using NServiceBus in this video and the previous. Let's now explore what happens to events when the size of the message is larger than the accepted ones in the topic and the SQS. Like before, it puts a copy in the S3 bucket. So if I was to come back to the solution, let's make sure we go to the user created event. So let's open the messages and let's open the user created event. Now, right now, this event is very lightweight because all it has is the user ID. You could also appropriately have a date time that was created. So if you want, you can add a new property. So let's specify date time offset, which is going to have the created date time. Now, as a recommended practice, it's better to keep the events minimalistic and lightweight. But what if your event sizes grow larger? So let's assume you also have an image like before, which we used in the command. So let's make this as a string and pass in the image. So let's make sure we also set these properties in the constructor. Now, as soon as I come to the user ID property, Visual Studio is automatically suggesting to add these parameters. So let's hit tab and it automatically generates the properties. Now let's rename this as image. And let's also rename this to image. So let's make this as the property that we pass in. Now the place where we are publishing the event needs to be updated. So if we go to the create user command handler, let's pass in the new properties. So for the created datetime, let's pass the datetime offset.utc now, and let's pass in the image access. So let's use the message.image. Now once that is set up, let's run this and let's see what is happening. So we have the 3 services running and also our web API. So let's navigate to the post user. Let's click try it out and let's click execute. Now in this case, the image size is small, in which case the message will be passing through the SQS and SNS as usual. However, as the message size grows, it will not be able to use the SNS and the SQS. It will have to place the copy into S3. So let's update this string image property and let's place in a big string inside that, which is a base 64 encoded image like I used in the previous video. Let's click execute. And now you can see that this message is getting put into the S3 and will automatically expire after the timeout. So if we come back into our services, which is the task 4 service, this also uses the same S3 bucket to retrieve back the message. So if you look at the user service and the payroll service, all of them uses the S3 in this case. Now let's stop one of these payroll servers and let's send the message again. Now you can go to the payroll service queue and see this message inside there. So now if I double click the payroll service and refresh this, you can see one message inside this. So let's double click this. Here we have the S3 body key, which has the pointer to the object inside the S3 bucket. Now if I close this and navigate to our S3 bucket, so let's double click and let's go into the user folder, you can see all the objects inside here. Now the right one that we are looking at is basically the one which ends with DC0. So if we navigate to the first item, which is the item that is the message. So now this has the entire string as the image size, and it also has the name and the ID in here. Now as soon as the payroll service comes back up again, it is going to process this message and ultimately it's going to remove these messages from S3. So let's navigate back, let's run the payroll service, right click, debug, and let's start new instance. Now this is going to pick up the message from the S3 and it's going to process it and call the payroll service user created handler. I hope this helps you to understand how to publish events using NServiceBus and SQS Transport. We saw how NServiceBus uses Amazon SNS and sets it up for each event. Each of the event has an appropriate topic and it has the subscriptions automatically created based on the handlers that we create. Now, anytime you create a new handler, it will automatically create a subscription to that topic. If you like this video, please make sure to hit the like button. If you have any questions or feedback, please make sure to leave them in the comment section below. If you want to be notified of future such videos, please don't forget to hit the subscribe button. It'll also help me to grow this YouTube channel. Thank you and see you soon.